Good day, students. Welcome to ISIFE EDUBLOG. My name is Samson, aka Igwe. I'll be taking you guys on chemistry, and the topic we'll be dealing on today is the acid and base concept. This is the preview of the topic, the various people that worked on acid and base and their various definitions. The example is the Arrhenius acid base, another one is the Bronsted and Lowry acid base, and another one is the Lewis acid base concept. If today is your first day of coming across this channel, you can hit the subscribe button so that you can get more update and the various past questions on the topics. And some of the past questions you will find there is WAEC past question and their answers, then the JAMB past question and their answers, and the POST UTME past question and answers for all schools. Try to hit the subscribe button so that you can be updated from time to time, and you'll be getting more information. So we will center on our discussion now, which is acid and base concept. You know, over time, people have been finding various ways to define acid and base, and everybody is just saying what they think an acid can be as well as a base. But the first person to define acid is called Arrhenius, or you can simply call him Arrhenius, and we coined his own concept as Arrhenius acid-base concept. So Arrhenius defined acid as a substance which ionizes in water to produce a hydrogen ion as the only positive ion, while a base is a substance that ionizes in water to produce a hydroxide ion as the only negative ion. In other words, according to Arrhenius, for anything to be an acid, it must be able to produce hydrogen ion, and for anything to be a base, it must be able to produce hydroxide ion. So, the Arrhenius definition of an acid, from his definition, we can see the various things he called an acid. That is Arrhenius acid. Example is HCl. If HCl ionizes, it produces hydrogen ion and chloride ion. If H2SO4 ionizes, it produces 2 hydrogen ion and sulfate ion. If nitric acid ionizes, it produces hydrogen ion and nitrate ion. So, according to Arrhenius, he said that for anything to be an acid, it should be able to dissociate or ionize in water to produce hydrogen ion. If you look at all these, what they have in common is hydrogen ion, and that is the concept of the Arrhenius. Said that an acid they ionize to produce the hydrogen ion. Then examples of Arrhenius base. We have sodium hydroxide. When it ionizes, it produces sodium ion and hydroxide ion. We also have potassium hydroxide. When it ionizes, it produces potassium ion and hydroxide ion. We have calcium hydroxide. When it ionizes, it produces calcium ion and hydroxide ion, and the rest of them. So what is common to these bases, according to Arrhenius, is the hydroxide ion. That is why he defined a base as a substance that ionizes in water to produce hydroxide ion. In other words, for anything to be qualified as a base, it must have hydroxide ion, according to him. But despite this definition he has given to an acid and base, there are limitations to those definitions. So we talk about the limitations of the Arrhenius acid-base concept or definition. One of the limitations is that he considered water as the only solvent. That is one of the limitations of Arrhenius acid-base concept. Everything he was talking about is water, this, water, the other one. But there are other solvents apart from water, such as liquid hydrogen fluoride, interhalogen compounds, the aqueous ammonia. All these things are solvents, but he's concentrating everything on water. So one of the limitations is that he considers water as the only solvent. Number 2 limitation is that he could not be able to explain why something like ammonia and calcium oxide are bases, but they don't have hydroxide ion. Like he said that a base, they produces hydroxide ion, but something like ammonia is a base. But ammonia cannot produce hydroxide ion. It doesn't have it. So there's no way ammonia can produce a hydroxide ion, unlike these ones. So he couldn't explain why ammonia is a base, but it cannot produce hydroxide ion. Another limitation, the third one, is that he said that acid ionizes to produce hydrogen ion in water, but it is not possible to get ordinary hydrogen ion in water. Hydrogen ion is an electrophile, so once a hydrogen ion comes out, it will try to attach itself with the water molecule to form what is called hydronium ion. So whenever an acid ionizes in water, it is not hydrogen ion that will be isolated in a free state. What will be produced in a free state is the hydronium ion. That is something like this, H3O plus, and not this. So in the presence of water, this cannot exist freely. What will be formed is this, because water is a molecule like this. Water has 2 lone pairs of electron, and once the hydrogen ion, which is an electrophile, comes in contact with the water molecule, then hydronium ion will be formed. So these are the limitations of Arrhenius acid-base concept. And the second set of people, which is Bronsted and Rowley, they try to improve on the limitations of Arrhenius, and they gave their own definitions. Bronsted is a man working in a different place, and Rowley is another man working in a different place, but both of them said exactly the same thing, and because of that, they are merged together, and what they worked on, we can classify it as a Bronsted and Rowley acid-base concept. Bronsted and Rowley. Bronsted and Rowley acid-base concept. We said that Bronsted is different from Rowley. Bronsted is a man and Rowley is another man, but for the fact that both of them said exactly the same thing, then 2 of them are merged together. Now, what is the way they define the acid and the base is this. According to Bronsted and Rowley, an acid is a proton donor. Acid is a proton donor. Acid is a proton donor. Proton donor. That is anything that can donate proton. While a base is a proton acceptor. Proton acceptor. That is anything that can accept a proton. So, examples of Bronsted and Rowley acid and base reaction is this. HCl reacting with ammonia will give us a product which is ammonium ion plus chloride ion. In this case now, this is the acid and this is the base. And why is this an acid? The reason why it is an acid is that it is the one that donated proton. Remember, acid is a proton donor. So this donated proton and this one accepted the proton. The number of proton here is 3 before, but now it is now 4. Then this one that donated proton becomes the acid. Then this one, base, is a proton acceptor. The one that accepted the proton becomes the base. Then this product that is formed now is called the conjugate acid. Conjugate acid. Then this one now is the conjugate. So anytime a Bronsted acid reacts with a Bronsted base, we have a conjugate acid and conjugate base. And how will you be able to know the one that is acid and the one that is base? It is simple to spot. The acid is the one that donates the proton. That's proton donor. Proton is the hydrogen ion. It has donated the hydrogen ion to this. It now becomes 4. Then this one that accepted becomes the base. And the conjugate acid simply means an acid that is formed when a base accepts proton. An acid that is formed when a base accepts proton. So ordinarily base, they cannot donate proton, they will accept. And whenever they accept a proton, they form what is called the conjugate acid. And an acid is a proton donor. Whenever an acid donates proton, you can't call it acid again, because what makes it an acid, it have donated it, and it is now a base called conjugate base. So from here you can now see that there is an improvement on the definition of acid and base than what the first man Arrhenius said. Arrhenius could not be able to explain why ammonia is a base, but from this man's concept we can see that ammonia is a base here because it accepted a proton. But according to Arrhenius, he said that bases, they donate hydroxide ion. Okay. So another example on this is water plus NOH3. This will give me ammonium ion plus hydroxide ion. So in this case now, water is the one that donated proton. So since water is the one that donated proton, the water becomes the acid. So this one is the one that accepted the proton, it becomes the base. Now this is ammonium ion. The ammonium ion is the conjugate acid. Conjugate acid. Because it is the acid formed when the base accepts proton. Now that acid that loses proton is the conjugate base. So this is the conjugate base. You can now see that water is acting as an acid here, because it's the one that donated the proton. So according to Bronsted and Lowry definition or concept of acid, for anything to be an acid, it should be able to release or donate proton. Then base, they should be able to accept proton. And when a base accepts proton, we call it a conjugate acid. When an acid loses proton, it forms a conjugate base. So that is the way they define the acid and the base. Then the next person that worked on acid and base is G.N. Lewis. G.N. Lewis. So we talk about the Lewis acid-base concept. Lewis acid-base concept. Lewis acid-base concept. According to G.N. Lewis, an acid is an electron pair acceptor. An acid is an electron pair acceptor, and a base is an electron pair donor. Electron pair donor. So the Lewis, he was using the concept of electron to define acid, whereas Bronsted and Lowry, they were using a proton to define acid. But according to Lewis, he said that an acid is an electron pair acceptor. Anything that can accept a pair of electrons is called electrophile. So you can also say that an acid is an electrophile. Then the base is an electron pair donor. And anything that can donate a pair of electrons is called a nucleophile. If you don't want to call it a nucleophile, you can call it a ligand. Ligand are electron pair donors, or the Lewis base. So let's see example of the Lewis acid-base reaction. So in this case now, this is the one that is accepting a pair of electrons, because it doesn't have electron. Hydrogen ion does not have electron. What has one electron is hydrogen atom. But when hydrogen atom loses an electron, it becomes hydrogen ion. So this hydrogen ion now does not have an electron, but water has an electron. So when water donates an electron to it, it will now form the hydronium ion. So this one that doesn't have an electron is the Lewis acid. Then this one is the Lewis base. Then the product of the Lewis acid-base reaction is called an adduct. Adduct. That is the general name for the product of a Lewis acid-base reaction. Whenever a Lewis acid reacts with a Lewis base, the product is generally called an adduct. But this is a hydronium ion. Hydronium ion. Hydronium ion. Okay, another example is this: hydrogen ion plus ammonia. Ammonia donated electron to this, Then the product will now become NH4 plus. This is ammonium ion. Ammonium ion. And this ammonium ion, we can simply call it an adduct. Adduct is a product of a Lewis acid-base reaction. So from here now, hydrogen ion does not have electron. It can be called the acid. This is the acid. Then this other one that has the electron, the pair of electron to donate, is called the base. So the Lewis acid combining the Lewis with the Lewis base will give us the adduct. So when we are talking about the Lewis acid, they are those ones that doesn't have an electron. They are the acceptors of electron, while the Lewis base are the donors, the electron pair donors. So these are the examples of Lewis acid-base reaction. So in conclusion, we see that there are various ways you can define acid, and they include the Arrhenius acid-base concept, the Bronsted and Lowry acid-base concept, and the Lewis acid-base concept. In the Arrhenius acid-base concept, it just defines acid as a substance that ionizes in water to produce hydrogen ion, and the base ionizes in water to produce hydroxyl ion. But there are limitations to that, because some of the bases does not have OH ion. How can they produce OH ion since they don't have it? But there are improvements on that, as given by Bronsted and Lowry. Bronsted and Lowry independently define acid as a proton donor and the base as a proton acceptor. Then the last person that defined acid, which up to today we are still using his own definition, is the G.N. Lewis acid-base concept. And Lewis did not define acid according to Bronsted, because Bronsted, they were using proton to define acid. They say acid is a proton donor, base is a proton acceptor, but this man, G.N. Lewis, defined based on electron. He said that an acid is electron pair acceptor. And the electron pair acceptor, like we say, is an electrophile. Electrophile simply means electron seeking. Any substance or any species that is seeking for electron is an electrophile. It doesn't have, it is looking for electron to attract. Then the base is an electron pair donor. So electron pair donors are also called nucleophiles. Nucleophiles, they are looking for the nucleus and they have an electron to donate. The nucleophiles are also called the ligands, the electron pair donor. Like when you talk about the transition metal complex, the transition metal or the central metals are the inside, but the ligands are those ones that are surrounding it, because they are Lewis base. They can be able to donate electron. So if they can only donate one electron, we call them the monodentate ligand. If they can donate 2 electrons, they are called the bidentate ligand. If they can donate 3 electrons, they are called the tridentate ligand. So another name for the electron pair donors is the nucleophiles, or you call them ligands.